Organic compounds. Carbon. Carbon is the backbone of biological molecules. Organic chemistry is the chemistry of carbon compounds. Carbon has the ability to form long chains, enabling the creation of large molecules, proteins, lipids, carbohydrates, and nucleic acids. Organic molecules consist of carbon atoms covalently bonded to each other and other atoms, most commonly hydrogen, oxygen, and nitrogen, and frequently phosphorus and sulfur, and occasionally other trace elements such as the halogens. Carbon atoms can form diverse molecules by bonding to 4 other atoms which are in different directions. This allows the molecule to take on a 3D configuration. It is this 3D structure that defines the molecule's function. Carbon has 4 valence electrons with which to make covalent bonds. Valence electrons are the electrons in the outer shell. The inner electrons can't form bonds. A covalent bond forms between 2 atoms. Each atom shares at least one of its outer electrons with the other when the bond is formed. The result is a pair of electrons being shared, one from each atom, to form a single covalent bond. If a carbon atom is bonded to 4 other atoms, it will share one of its electrons with each of the 4 other atoms, making 4 bonds. In this diagram of methane, the central carbon atom has formed 4 single covalent bonds, one with each hydrogen. The carbon atom has shared one of its electrons with each hydrogen, while each hydrogen shares its electron with the carbon. The result is a pair of electrons forming each bond. Single bonds are shown by straight lines. If carbon bonds with fewer than 4 other atoms, it can share more than one of its electrons with one or more of the other atoms. If it shares 2 electrons, it forms a double bond. If it shares 3 electrons, it forms a triple bond. Both types of bonds are illustrated here with carbon dioxide and carbon monoxide. Carbon doesn't form quadruple bonds. When bonded with 4 atoms, carbon can only have single bonds with each atom. Double and triple bonds can only occur when fewer than 4 other atoms are bonded to carbon. Double bonds are stronger and shorter than single bonds, and triple bonds are even stronger and shorter. On diagrams, single bonds are represented by 1 line, double bonds by 2 lines, and triple bonds by 3. Hydrocarbons. These molecules consist of only carbon and hydrogen atoms. Each carbon atom makes 4 bonds. Each hydrogen atom makes 1 bond. Carbon-hydrogen bonds are nonpolar. The nonpolar bonds have a major impact on hydrocarbon behavior. Fossil fuels are examples of hydrocarbons that are formed from decaying organic matter. Water is polar, so it will attract other polar molecules. Since hydrocarbons are not polar, they will not be attracted to water and will not mix or dissolve in water. Oil, which is a hydrocarbon, and water don't mix. Because hydrocarbons are not attracted to water, they are classified as hydrophobic. In saturated hydrocarbons, every carbon atom is bonded to 4 different atoms, and no new atoms can be added along the chain. In unsaturated hydrocarbons, some of the carbon-carbon bonds are double or triple bonds. Those can be broken and replaced with a single bond. At that point, additional atoms can be added. The carbon-carbon double bonds create kinks on the hydrocarbon chain.